Today, actually, we are looking at the limits and continuity. And as much as we want to talk about limiting, it's also to note the importance of limits. Where we talk about limits in the sense that they help us to understand the graphs of the functions, the continuity, the asymptotes. It also help us to understand the entire topic of calculus, especially in differentiation by the first principle. What limits are is they are there to describe how the function behaves is their unknown value, their independent unknown value approaches a certain value. How does the function behaves? We can see that in terms of graphs. So I'm going to try to help you understand the functions as I'm using graphs as well. So the function that I wrote on the board, it reads as follows. How do we read functions? Actually, it reads um, the limit, the limit as x approaches a um, f of x is L. That's how one can read this. The limit as x approaches a, the function f of x is approaching the value L. So we are saying, for example, let's use this example one. As the limit x approaches 3, the function f of x, x squared, approaches 9. We are saying if x, or if we get arbitrarily close to this number, right? It simply means if x is approaching 3, we arbitrarily approaching 9. How does that work? Remember, as we approach x, I'm going to give a number line where we have 3, 0 here. So we approach x from two different directions. We can approach x from the positive direction, or from the right side, or we can approach x, negative 3, I mean, from the left side. So from the left side, the value that is closer to 3, we can approach that, let's say, 2.9. So if we say 2.9 squared, what value do we get? That would be 2.9 squared. That gives us 8.41, right? What if we approach more further, like 2.99? That will be 2.99 squared. It will be 8.9401. If we approach more closer, 2.999, right? 2.999 or 99 squared, we're gonna get 2.99999 squared. If we approach from that side more closer, we're going to get 8.99994. To get that, we are getting closer to which value? We're getting closer to 9. If we approach from the other side, let's say we are approaching it from the right side, let's say from 3.01, 3.01 squared. If we approach from there, 3.01 squared, we're going to get 9.0601. So the more closer we come to 3, like 3.001, right? 3.001 squared, right? 3.001 squared is going to be 9.006001. So you can realize that from both sides, as far as we are coming closer to 9, to 3, the value that we are approaching is 9. So that's why we say the limit is 9. So that's why we say we're going to say, actually, as much as we're getting closer to 3, um, uh, we will get um, arbitrary, arbitrarily close to 9. Right. So that's how limit works. Is when the unknown of the function is approaching a certain value, uh, arbitrarily we get to another value, and that value is what we are looking at. How does the function is responding as we get closer to a certain value from both sides, left or right? Let's look in the example 2. Example 2. Example 2 will say the limit as x approaches um, infinity, positive infinity, on 1 on x is equals to what? Right. As much as we are getting closer to positive infinity, actually, let's give this graph is something like this, I guess. Um, the limit as x approaches the infinity, what will be the value being approached by the y of 1 over x? This function, what value is it getting closer to? When we say positive, it's we're saying if we have a rational function and our numerator, our denominator is getting bigger and bigger and bigger, you're going to realize that the value we get at the end of the day, it becomes smaller and smaller and smaller. The bigger the denominator, the smaller the value it approaches. So as the denominator becomes very big, therefore the value it approaches is going to be small. For example, let's say 1 divided by 10. If we say 1 on 10, we'll get 0.1, right? If we say 1 over 100, we get 0.01. So the bigger the number, the smaller the value it approaches. So definitely, you're going to realize that the value that is being approached here is 0. Because if we say 1 over million, it's going to be a very tiny number. That tiny number is getting smaller and smaller and smaller and is as good as big as nothing. It's not going to be nothing, but it's as good as nothing. So we are saying the real value arbitrary that is being approached is 0, right? Okay, let's try to use a left-hand graph. What if we have a situation of 3 as the limit uh, x approaches 0 on the function 1 on x? What would be the values being approached? Something has to be very careful now. Here is the reason why sometimes you realize that if you punch 1 over 0, you're going to get 0. And this should tell you that when we are looking for limits, we are not actually just substituting values into the functions to get the values we want, but it means we are approaching the value. What value do we get? But here we are going to see something very different and very fascinating. And that's the reason why if you press on our calculator, if we say 1 on 0, the answer is undefined. Why is it undefined? Let's find out. We're going to realize that if we have this graph, it's going to be, remember, we don't divide by 0. So definitely we are going to have a vertical asymptote on the 0. So which means our graph is not going to get there. And as we stipulated in example 2, we clearly see that this is 0. As x-axis approaches the infinity, which is this side, our y value is getting smaller. Our y value is getting smaller, is going to approach this one. It's approaching 0, but it will never reach 0. That's what we have noticed. That's when we approach as our x is approaching 0 from the right side, which means from this side, right? If x is approaching 0 from this side, we realize that the value gets a little bit smaller, right? And as we are approaching our x, our 0 from this side, what happens to y value? Is it going to approach the same direction like the graph? Is it going to be something like this? No. We are going to realize that the value as x approaches 0 from the negative direction, right? Our value is going to be very small. So we are saying the more we are getting this side, our y value is getting very smaller, right? Okay, so which means we are going to have two different notations. We're going to say as the limit x approaches 0 from the positive side, right? Our function is going to be positive infinity, right? And